In this video, we'll learn about the variant data type, which was made production ready in ClickHouse 25.3. So this type represents a union of other data types. So for example, if we had a field of type variant uint64, string, an array of uint64, we could store numeric values or strings or arrays of numbers. Let's launch ClickHouse so we can see how this works. So we're going to start by learning how to create a value with the variant type. And the easiest way is to cast the value. So we'll say we've got 2.5 and we want it to cast it to a variant of float64 or string, and then we'll get back the type name afterwards. And you can see it comes back, we've got our value, and the type is variant float64 and string. Now you can't cast it if the value can't be cast to a value. So if we update our variant to be uint8 and boolean, you see we get an error saying it cannot pass the text value into this variant type. We can use the variantType function to see which of the union types is being used for a particular value. So if we go back to our first query and then we'll call variantType value, you can see that for this particular value, it's a variant float64 or string, but it's using the type float64 for the value 2.5. What if we replace float with uint and then run the query, and you can see this time the variant type is now string because it can't be cast to uint32. Let's try something a bit more complicated. So we're going to have an array of values. We've got 1, ClickHouse, and 2.5. We'll use the array join function to kind of explode those arrays of values out into individual rows, and then we'll return each value, the type name, and then the variant type as well. And you can see it immediately fails, saying there is no supertype for types uint8, string, and float64. Now, if we want that to work, so if we have these differing values, we can use the setting use variant as common type, set that to 1, and you can see we now get back the variant float64 string and uint8. The first value is uint8, the second one is a string, and the third one is a float64. If we want to read the underlying values as their proper type, we can write a period followed by the type name. So for example, value.uint8, value.string, and then value.float64. And you can see we get back for the first row, uint8 is a 1, string and float64 are nulls because there's no values for that value for those types. And then for the second one, string has ClickHouse, uint8 and float64 are null. And then for the last one, uint8 is null, string is null because it's a float64 value. Next, let's see how to use the variant type when reading data from files. So I'm going to read some values from this data.csv file I've got, and you can see it comes back and it's kind of gone up to the super type. So everything is a nullable string. So if we don't want to have everything as a string, we could add a schema inference hint and tell it I want it to be a variant uint16 or string. And then if we run that query, you can see it is now using that type on each row. Alternatively, we can use the setting input format try infer variance, set that to 1, and it will then infer it to a variant type itself. And you can see this time we've got a float64, int64, and string. And then we can create a table from this as well. So we'll say create a replace table data order by ID as, and then we'll just change that to select star. And you can see this fails because we can't have a variant type as the sorting key. So let's go and update that. So we'll just have it as an empty tuple. And now let's write a query against that table to get the ID, the type, and the variant type, and you can see it comes back with the various values. Finally, let's see how to cast from the variant type to other types. So we'll try casting it to string, and this is the super type for all the other types, and you can see that works successfully, so now all the values are a string. But if we try int64, this isn't going to work because int64 isn't a super type for all the other types in our variant type. So the variant type is one of the building blocks for the JSON type. If you want to learn more about that, check out this video next.